Hey, what's up folks, and welcome back to another Layer by Layer. In today's tutorial, we're going to take a look at the MX MIDI guitar project. Definitely check it out. We have a link in the description of this video. This is a collaboration project with Liz Clark. She put together the code in CircuitPython, and I did the mechanical design. So today we're going to take a look at Fusion, and just to kind of show you the process of adding parts to this already massive build. So let's go ahead and jump into Fusion 360. So I wanted to give you guys an inside look of how you can structure your assemblies so that they are a little bit more easier to work with, especially when you want to add more parts and scale different pieces to the design. So the first thing I want to show you guys how to do is to add more Cherry MX switches to the neck of the guitar. So currently I have 12 of them. They're all lined up here, and it's really cool when you can drive the geometry with a user parameter. So I have quite a few set up here. Some of the common ones that I like to use all the time is like the shell thickness. I have that one here called shell, and I also have the gap, which tends to be a little bit of clearance that I like to add for things that need to kind of press fit or just kind of have some clearance for things to mate. So that's what we have here. The other thing I wanted to show you is the neck length. So currently I actually have one set up. It's set to 230 millimeters. So if I'm going to add more to this, I kind of need to increase the length of the neck. And thankfully I've set it up so that when I change this value, it hopefully doesn't break anything. So let's go ahead and try it out. So I'm going to put 300 in here and take a look at the design, and Fusion is going to recalculate all the different features, but there it is. It has increased it. And it's really important to note that the Cherry MX switches is being driven with a pattern. So not only that, but it also has a joint that's associated to it. So if I click on one of these and start dragging, you'll see where the joint is set. I actually just set one Cherry MX switch, and then I did a pattern, a rectangular pattern, and then just have it going along one direction. So let me undo that. You also notice that if we do a cross-section analysis, you see there's some actual stuff in here. There's some more electronics inside the neck of the guitar, not just the switches. We actually have a little LiPo battery, an accelerometer breakout, a slide switch, and another microcontroller. This is the Feather, Adafruit Feather. So all that stuff is living inside of the neck of the guitar. So when I was sketching this out, I wanted to make sure that I drove the positions of these components with joints. That way, when things scale, those joints can scale along with the geometry. So if I go ahead and open up our user parameter window again and set this 300 value back to 230, you can see how everything gets compressed. But because we're using joints, things are flowing with the design, and that's really critical. You'll see that in the back here, we actually have some screws that attach to the rest of the body of the guitar. And then over here in the other end, we have, again, some holes and some screws to attach these pieces together. The neck of the guitar is actually made from two pieces. You have this cover that snap fits into a sort of a case, right? So that's the way that is set up. So now that I have, well, let me go ahead and change this back to 300, and then we can see how everything kind of scales and stretches. You'll see the feather gets further away, but it's still kept where it needs to be near this end here. And these guys kind of spread out a little bit, and that's just because of the way they were set up in the joints, the rigid joints too. Okay, so we have that. The next thing I need to do is add more of the switches themselves. So the way I have the component structured is I have all of my parts, my electronics, inside of a component called electronics. And then inside of electronics, I have another component that's called MX switches. So I knew ahead of time that I would be using a lot of them. So I figured, well, I better go ahead and nest that component in its own component so that if I need to use a pattern, everything will get nested in this component as opposed to being just a bunch of those Cherry MX switches inside of the electronics. So just kind of knowing that you're going to nest stuff is kind of good to do before you actually do it, I guess. Okay, so if we just activate the component for the MX switches, you'll see all that's in here is just the start of it, which is importing this as an external component, and then using the rectangular pattern to, well, make more of them. So I'm going to go ahead and double click on this guy. And you can see here in the edit feature window, where we have a distance of spacing, and we actually have a user parameter set up for the spacing, the distance between each one of these guys. So I actually have that. I figured that that would be something that I would have to change, but the quantity is a fixed number set to 12. So instead of just adding 16 here, I'm going to hit escape or cancel, and then bring up my user parameter window, and I'll create a new one, and I'll call this MX quantity. I think that's a good one. MX quantity, like that. And for the unit, we need to set it to no units because it just needs to be a number. And if you set something like millimeters or inches, it just won't work in the feature when you're editing the feature. So this is going to be 16. I'll hit enter, and then I'll hit OK. So now when we go and double click on our pattern feature, we should be able to just type in here MX quantity. You can see here I have the 2 because I just typed in MX, so I'll just click on quantity. That seems to be okay. I'll hit enter. Now, it's always really important to test your user parameters as soon as you apply them, because sometimes Fusion has some caching issues. I'm going to just blame it on caching issues because I don't really know what it is. So let's go in here and change that 16 back to a 12. Let's see if Fusion took that number. And it did. Excellent. Again, it's just always important to actually see and test your user parameters when you apply them. And also just an interesting note is that this number, the way the number scheme works is it tends to keep adding more of them. You can see here, this is like 15, 16, and just so on and so on. Not really important, but if I change this to 16, you'll see that the number is actually incrementing a little bit differently than you would think. Well, maybe not. All right, well, that's cool. All right, so I have 16 again, and that's good. So the next thing I want to do is, of course, I got the switches, but if we hide the whole switch component, you can see I still have only 12 of these holes. We need these holes in order to kind of mount them to this cover. So what we need to do is we can leave our switches off for now, and then activate the main component. And then what we can do is look for the neck. So the neck is structured in a way where I have everything inside of the main guitar, and then I have things inside of the neck. The neck itself has those two components, the top and the bottom. So we need to work on the neck top. So I'll activate that. That way my timeline gets nice and isolated. And then I could also right click on that component and say isolate. That way all I am seeing is just that one body, that one component. All right, so how am I creating these holes, right? Well, it's actually driven in a very similar way. I create one extrusion and then I repeat that with the pattern. So inside the pattern, I should just be able to type in, get rid of this quantity hard-coded value of 12 and just change that to quantity. So there's the MX quantity, and it looks okay. I'll hit OK. So let Fusion recalculate all the things, and there's all our stuff. It's looking pretty good. So I'll go ahead and bring back, or actually right-click, unisolate, and that should bring everything back, at least the bodies. And then I think I still have the Cherry MX group hidden. There you go. So I just showed it. So now you can see that they're all there, and it looks pretty decent. I could do another cross-section analysis. Just turn on the analysis folder, and there should be the same one there. And if you want to get rid of that ghosting effect, well, that's because I still have the top neck component activated. So I'll just go ahead and right-click, activate the main root of the document. And that way we can see everything. Turn off analysis. All right, so that's the first thing I want to do. Pretty easy. We added another user parameter. And if we wanted to mess with things, we could mess with things. Like the MX spacing, again, that's the spacing between the keys. That is all there for us to change as well. So if we're using different sized keycaps, those aren't modeled here. Unfortunately, I didn't model those, but somebody could model them easily and then use that in this design and reference that. Probably even drive it the same way where you're using a pattern to patternize that and using the same parameters. When you update any of those, they'll all update. So that's another tip there. Okay, so now that I have those set up, another thing I wanted to add is just one more potentiometer. So right here we have two potentiometers. One controls the modulation, and another one controls the accelerometer. But if we wanted to do something that it controls maybe something else, we could add another one. So how would we do that? Well, the way it's set up is, let's go ahead and dive into the body of the guitar. And we have the body set up so that it's the top and the bottom. So if I hide the top right now, you can see all the components inside. And what we probably want to do is get rid of the hardware screws for just a second, because they're all over the place. Hardware screws, I have that in its own component. I'll go ahead and hide that. You can see here that they are panel mounted. There is nothing really special about the way they're mounted other than the size of the hole, I guess, for the top. But you can get an idea of the clearances between the two potentiometers and making sure that it doesn't hit any of the cabling or any of the wires or any of the other mechanisms rather. So it looks pretty simple, right? So inside of the body top, we have some sketches, and the one we want to look for is called potholes. So potholes, I'm going to right click on that and say show dimensions. You can kind of get an idea of how this guy has been structured. So I have this rectangle sketch, and there's two circles in it. Each circle has some dimensions set to it so that it has some distance between the other lines, and just about everything has a dimension, and it's all following this center origin. So this little guy here is the center origin, and really the reason why everything is kind of behaving properly is because I am referencing the same origin, the same center for all of the components. They all tend to have the same center. That way everything's consistent, and when I need to change something that's big, I'll have a reference point that will follow everything. So that's why I have this center thing here. Cool. It's really important to do that. All right, so to add another one of these guys, I'm not using a pattern. I'm going to have to make a copy of it. So let me go ahead and I'll leave the sketch open for now, because you can kind of do it either or. You can either make the hole first or add the component first. So I think I'm going to add the component. And what I like to do is I like to kind of keep my timeline a little bit consistent. So if I scroll all the way back in my timeline, I should be able to get to a point where I first added the potentiometer. So somewhere around here. So I'm going to roll my history all the way back here. And I can kind of pull out this electronics bin folder and then start seeing where I start creating these potentiometers. So right about here is where I create them. And it looks like I made a copy here. So I have two of them here. And what I'll do here is just select that component, the pots component. I knew it was going to have at least two, so that's why I created that pots folder and then brought it in there. So you can see the timeline. It just shows those two, and that's it. So I'll grab one of these, and what I'll do is I'll hit the M key. That's a hotkey for move or copy. The move or copy command is great because it can do two things. It can move and copy. So I'm actually going to do that. There's a checkbox here, create copy. I need to make sure that that is selected. Then I can start moving it to make that copy. So somewhere around here. Doesn't matter where it is as long as you have kind of a general idea of where it could be. The first one is kind of in there because it's just, I haven't assigned something to this yet. So that one's floating around there. Let me revert that. All right, so now that I have that set up, let me jump back to the main root of the document and start finding out when I start applying those joints. And that could take a while. There we go, somewhere around there. So this is, oh, it's actually right here. This is money right there. Okay, so the next, now that I have those components in there, and they're in the right kind of component that I want, I can start modifying this sketch so that I can have another hole to extrude from. So I'll go ahead and just double click on the potholes, or right click Edit Sketch, whichever you like. And then the way I'm going to add it is I just want to make it in the center. Fusion does a really good job of doing midpoint constraints automatically, because this is the midpoint of this line, and that's kind of where I want it. I'll use the same diameter, 7.5 is good. And then I'll hit OK. That's it. So the next thing here is right next to the sketch and the timeline is the extrusion that creates that cut, that hole. So if I double click on it, I can actually append that new circle profile that we just added to the feature, and just enter, and then that is the new hole. Excellent. Now the problem is when I start applying these joints to the components, we might run into some clearance issues. So let me actually add the joint and then see and then deal with the clearance issues. So if I forgot how I set up the joint, I could just double click one of these joints, one of the pots, and just kind of reference, okay, my angle's 90 degrees and my offset's negative 4.5. That's going to be handy. And you can also get an idea of where you actually selected that joint. If you select snap, you can see which line you selected. And for whatever reason, Fusion just said, you don't need to see that. Let me push it all the way down so you never see that again. So let me go ahead and apply a joint with the hotkey J. And then it'll be something like this line. I'm pretty sure it was this line. And then it'll be this top circle here. So do that. And then remember we saw 90. And then the Z offset was negative 4.5. And if we look at it straight on, you can see that lines up perfectly with the rest of them. I'll hit OK. And now that's set. Excellent. Now, if I hide the bodies, you can see we are crashing them into each other. They're intersecting with each other, so that's bad. So what we can do is just turn on that potholes sketch, and because I am showing the dimensions, I just right-click Show Dimensions or right-click Hide Dimensions. I want to show them so that I can modify and tweak these values while I'm looking at them, because if I were to edit them, it would jump me into the back. It would jump the timeline backwards to the point where these weren't there, and I wouldn't be able to kind of make that judgment call of, is there enough clearance? So that's why I like using these show dimensions. So, some problems here that arises is that we kind of want to change the way this is dimensioned out. So I actually don't like that this is a hard-coded value that's saying, oh, push this set 44 millimeters away from the center. I actually want to make this a little bit easier. So I'm actually going to go into the sketch and start modifying some stuff. As you saw, now look at the timeline. It actually went backwards to the point where this was created, and that means all the things aren't there yet, like the joints. So boohoo. So I'm going to go ahead and delete this 44 here because I don't think that's a good way to drive this. And now I can freely move this guy on one of the axes like that, right? I still have a sketch dimension over here. And that's set to 36. If I didn't want that, I could get rid of that too. But really, I just want to center this out with this mechanism here, the strumming mechanism. And if we look carefully, we actually already have some lines that were projected from that mechanism. So that's cool. So I can use these guys as a reference point. So what I'm going to do is I'm going to create a construction line to connect these two ends together. And then I'll select that and just hit X. That way it's a construction line. And then I'll create another line and then roll my thing here until I hit that midpoint. I hit that midpoint, and then I'll connect it to the other midpoint of that rectangle that's driving those three circles. So click on that. Now all I got to do is straighten this out by applying a horizontal or vertical constraint. And now we have that. I'll go ahead and select that, hit X again, and now this is centered with these two edges here because I created those construction lines. And Fusion did a great job of just automatically applying those constraints for me, especially the midpoint constraint. So now that's set up, it's in the center, and now I need to kind of play around with it. So I'll hit Finish Sketch. Now that it'll jump me back into the future where I applied these joints, and I can actually mess with these guys. So I can say, let's try 70. You can see that's looking pretty good. 70, 72, etc., etc. So we can keep playing with it if we want, but for now that's looking okay. I think that's decent distance away from them, decent clearing between. Oh boy, that was a tough tongue twister. Okay, so bring back the body. You can see, yeah, that's looking good. We're not crashing into anything yet. Maybe we're going to crash into something because further down the line, we do create a split body feature where we want to split this here. So this might actually get messed up a little bit. So let's go ahead and just go to the future. We have a lot of features in this timeline. So I'm going to go to this one right here, go to roll history over here. We're going to give Fusion a minute because it's got to calculate all that stuff again, all those joints, all that geometry. You can see a lot of sketches were created, and well, we're pretty good. Even though we cut here in this area, we still are okay. So if I hide these wings, and the reason why we split the body, because it's just so massive, we wanted to be able to fit it on 3D printer beds like the Prusa i3, so we designed it with that in mind. So that's why they're split, strategically split. So it looks pretty good. We can look around in here and see that there's nothing really intersecting. There's plenty of clearances for the wires and whatnot, so that's going to work okay. So there you have it, folks. That is how we can add more parts to an already massive build. And there's just a lot of wiring in it. So I'm going to bring these back over here. And yeah, it's really nice to be able to use user parameters. The double usage word's fun. And test your user parameters and really find a good method of using them where they make sense. There's some things here that maybe don't make sense, like they did at the time, but now maybe they don't make too much sense, like the HD width, that stands for the head. I could have wrote head, but I just put HD width, height, and length. I was adjusting the head quite a bit, so that's why I made that in there. But I could probably not delete them, but just not maybe favorite them. There are these little stars here that I think would prioritize them. The main things I think would be like gap and shell. Those are the main things that people I think are going to modify. But having the neck be driven with this was, I think, really handy. And yeah, that's going to be it. If you guys have any other ideas or things you want to take a look at, this is a downloadable file. I have it in several. I'll have it linked to the direct Fusion 360 shared link, but I also have the repo sites as well, so you can download the Fusion file directly and not have to wait for an email from Autodesk. But that's going to be it for today. Let me know what you guys think of the project and of this tutorial. Thank you guys so much for watching. I will see you in the next one. But until then, remember to make a great day. Bye, folks.